Hello everyone, thank you for watching this episode of the Lewis structure. So today we're gonna talk about that. Before we start, let's know more about the Lewis structure. The Lewis structure was named after American physical chemist Gilbert M. Lewis, who introduced it in the 1916 article "The Atom and the Molecule." This Lewis structure extends the electron dot diagram by adding lines between the atoms. So those lines represent bonds between the atoms of the molecule. The Lewis structure consists of an Allen symbol surrounded by one dot for each of its valence electron. This is like a shorthand notation, so atoms are written using the element symbols, and we connect them by a single line, which those lines represent bonds between the atoms. When it's a single line, it's a single bond. When it's double bond, there are two lines. When it's a triple bond, there is three lines between the atoms, like you can see here on the sulfur tetrafluoride. Here, those here are a single bond between sulfur and fluoride, and these dots here are lone pairs completing the octet for each atom of the molecule. So in order to get a Lewis structure drawn, we have to follow some steps. The first one is determine how many valence electrons each atom has in the molecule. The second one is if a molecule has more than one type of atom, we have to um, put in the center the least electronegativity atom. So if for those who don't remember how the electronegativity, how we can find the electronegativity is a trend that decreases as you move away from fluorine on the periodic table. Then after we find that, we have to arrange those electrons forming one single bond between each of them. Finally, we count the electrons around each atom. If each atom has 8 for an octet, then the octet is complete. But if the octet is not complete with one atom, then we have to follow to complete that octet. That will be the 5th step. So we have to make some arrangement between the single and bonds between the atoms, and maybe make it double or triple, so each atom has an octet. So they are happy when they have an octet complete. It's like the atoms are happy. So we start with a sample of how we do this. Remember, we first find the total number of bonds of electron in the molecule. Here we got 2 hydrogens, 1 carbon, and 1 oxygen on this molecule. So carbon has 4 electrons, 4 valence electrons, because carbon is located in the group 4 of the periodic table. Hydrogen has 1 valence electron, but we got 2, so we have to multiply 1 by 2. So we got 2. And then oxygen has 6 valence electrons because it is located on the group 6 of the periodic table. So we add them together and we get 12 total valence electrons. So the second step is to find how many electrons each of these atoms needs to be happy. Hydrogen only needs 2 valence electrons. Hydrogen always needs 2 valence electrons. That's why we put them on the ends of the molecules. Oxygen needs to fulfill the octet, and the carbon needs that too. So after we know that, we start to connect them by single bonds. Also, here the least electronegativity atom is hydrogen, but hydrogen mainly is put on the center. That's what we put on the corners. And the second least electronegativity atom is carbon. That's why we put it in the center. So we start to connect them by single bonds. Then after that, we have used 6 electrons. So we got 6 electrons left. Knowing this, we start to fill in the oxygen. So now we have used the 6 remaining electrons. But now we have to do some more steps, because you can see here that the oxygen has an octet complete, but here the carbon atom has only 6 electrons and it needs 8, so we need 2 more. In order to do that, we have to make a double bond here between carbon and oxygen, and now we have 8 electrons in the 8 bonds, 8 electrons on the oxygen and 8 electrons on the carbon. We got 2. We got 2 here, 2 more here, that's 4, and 2 more here, that's 6, and 2 more here, that's 8. And the oxygen has 4 here and another 4 here, so that's the octet that he does the octet complete. Now the Lewis structure for this molecule is now complete. Now we move to so here we got all the remaining steps that we talk about. Remember, hydrogen is electronegative of the element, but hydrogen is fairly the center atom of the molecule. So the next lowest electronegative atom is the carbon. That's why we put the carbon atom in the center. So after that, we count all the electrons, and we got 12. That's what we have in the first place. So now we got the molecule complete. So there is no leftover electron. So that the molecule, the Lewis structure for this molecule CH2 is complete. So another important thing to know about Lewis structure is that some molecules can be drawn by more than just one Lewis structure, and it doesn't mean that one of them is incorrect. It can be both can be correct. So here we have an example. We've got the CO2 molecule. So we start with the first step. We count the total of valence electron. We got 18 because we got two oxygens, and each oxygen has 6 because it's in group 6, remember? So we got 6 by 2, we got 12, and sulfur has 6 valence electron too, so we add them and we got 18. So we start to the structure for this molecule. So we put the sulfur in the center. This is the least electronegativity atom between those two, and then we connect the two oxygens atom by a single bond. So now we have used 4 electrons. So we got 14 left. Then we have to fill in the octet of the end of the electrons. So we got 1, 2, 3, 4. So now we have used 12. But now we have used 12 electrons, so we put 2 more on the sulfur. And if you can see, we have no leftover electrons, but the sulfur has not completely acted, so we have to make some arrangement between those single bonds so we can fill the octet of the sulfur. So we can do that in 2 ways. We can make a double bond with the left hand side oxygen, or we can make a double bond between the right hand side oxygen. And both Lewis structure are fine. So we got now 2 resonance structure for the same molecule. But it's safe to remember, or safe to say that the actual Lewis structure for the CO2 molecule is a hybrid between those 2 Lewis structures. So it's actually good to remember that. Also, the Lewis structure can give us a notion about the geometry of the molecule. We can know the angle that they forms and all that, but that will be for another lesson. And I hope you enjoyed that, and I hope you learned something about that, and we see another time. Thank you.